Welcome to video 7 of our virtual automation series. In the last video, we explored automating keyboard actions. If you want to check the video, you can find the link in the video description. In this video, we'll focus on working with positions and areas on the screen. You'll learn how to optimize image and text recognition for more flexible and accurate automation. This technique is useful in scenarios like automating help desk tasks, where you need to interact with different UI elements across varying screen positions, or in e-commerce checkout automation, where specific fields or buttons on the checkout page need to be identified and filled out dynamically. In today's tutorial, we will try out examples and see how it actually works. Before we begin, let's understand the scenario overview. At first, we will learn the basics of positions and areas on a screen. Then we will learn how to optimize image and text recognition by using dynamically positioned areas. After this, we will cover how to work with offset positions and offset areas. Make sure that the screen resolution on your virtual machine is same as the one on which you are going to create your automation flow. Any shift or change in the position of elements can cause challenges during automation. Let's get started. In the tutorials till now, we learned how to check position details of the images found with the help of Find Image block. We saw how can we hover images by using the position found as an input to hover position block. And, with the help of area property, how we were defining the exact area to look for the target image. Now, we will understand what position actually is and how its coordinates work with the change in element position on the screen. See, in LeapWork, position refers to the exact location of an element or image on the screen, identified by X and Y coordinates. The X coordinate represents the horizontal position, left to right, and the Y coordinate represents the vertical position, top to bottom. The top left corner of the screen is considered 0, 0, meaning both X and Y start at 0 at that point. Now, how these coordinates change with movement on the screen: as you move right across the screen, the X coordinate increases. As you move down, the Y coordinate increases. Let's say we are automating a test where you need to click a button located at a specific position. If the button's position is at 300, 200, it means the button is 300 pixels from the left, X, and 200 pixels from the top, Y. If the screen moves, like when you scroll or resize, these coordinates will change. For example, if you scroll down, the Y coordinate of elements on the screen may increase, because now those elements are lower on the page. This is what the position is all about. Let me capture the image on the desktop screen and hover it. To do it, let's capture the image. Yes, it's captured. How connect hover position block. And connect position found to position field of hover position block. Let's run the flow. And we can see, image was recognized by Find Image block, and the mouse hovered on the image capture. Here you can see the position details. Now see the point at which this image is found is at some X and Y coordinates. Now let's say, if I want to move the image to another new location and hover over it. To do that, let's connect offset position block. As we learned in the previous videos, the offset position block in LeapWork is used to adjust the position of an element relative to its current location on the screen. It allows you to move an element by a specified amount in the X, horizontal, or Y, vertical direction. Now connect found position as an input to position to offset property in offset position block. And since found position property is connected to the position input of the offset position block, the automation will adjust the location of the image, or element, that was found on the screen. Now, let's capture the position offset so as to define the offset value of new location. The offset value is defined with the help of vector. Simply drag the mouse to the new location where you want the position of the image to be adjusted to, or we can say move to. Yes, the offset value is defined in the terms of x and y coordinates. X is 469 and y is 162. That means the position of the new location is 162 pixels from the left and 469 pixels from the top. This is how you have to understand the details of element position in terms of x and y coordinates. Now connect result position to position property of hover position block. This will instruct the hover position block to hover image that is moved to the new location. Now, see it first. Find image block will find captured image on the screen. Then the mouse will move and hover over it. After this, the position of the image found will be adjusted to the new location based on the offset value we defined in offset position block. Then, the mouse will hover on the new position. Our flow is ready to run. Let's run it. And yes, we can see the mouse moved and hovered on the found image, and the mouse moved to the new offset location following the vector we had defined. We can see in the activity log that the image is found successfully. It's hovered. The mouse moved to the new offset position, and the position is hovered. This is how automating the process of changing element position on the screen works. Now, the next topic to learn is areas. In the previous videos, we learned how can we specify area in the text and numbers recognition so as to get the exact match easily. That's how areas play a very crucial role, especially in text and numbers recognition. If we don't specify the areas, there may be many challenges in the automation. Let's say the text you want to find may occur at several places on the screen. Or let's say the text you want to find may be at any location on the screen. So if we don't define area, the automation has to search for the image on the whole screen. That takes time and also lessen the chances of a successful automation. This is why defining areas is very important. But what area actually is? In LeapWork, when we talk about an area, we're referring to a specific part of the screen that you want to focus on during automation. This area is defined by x and y coordinates, along with width and height. When we talk about x and y coordinates, think of these as the starting point of the area. The x-coordinate tells you how far to move horizontally, left or right, from the edge of the screen. And the y-coordinate tells you how far to move vertically, up or down, from the top of the screen. When we talk about width and height of the area, this means that once you have the starting point, the x-y coordinates, the width determines how far the area stretches horizontally, and the height tells you how far it stretches vertically. So, when you set an area in LeapWork, you are actually defining a rectangle on the screen with a starting point, x, y, and a size, width and height. This helps LeapWork focus on a specific region, making it faster and more accurate when looking for images or performing actions. Like positions, we can also offset the areas of the elements on the screen. Now, you must have understood that area is the combination of the three elements, x and y coordinates, width and the height. The position defines where the area is, and width and the height decide the size of the area. When we offset the position, the area is moved. Now, when we offset the area, we change both the position and size of the area. Now, let's move to our flow and see how we can offset element area with the help of offset area block. Let's connect offset area block instead of offset position block. The offset area block in LeapWork creates a region on the screen based on a found image's position. Connected to the found position from the find image block, we are defining a new area around the position of the image found. Now, we will set offsets to move the area left, right, up, or down. Now, let's capture the size where we want to offset the image. Simply drag the mouse and capture the area. You can see that the size is captured in x and y coordinates. That means the mouse will move to 448 pixels to the right and 239 pixels down from the image position. Now comes the offset value, where we have to define the area of the new offset. The next step is to capture the area. This time, instead of vector, we have to define through the size and area. Now, observe. The area is defined in terms of x-y coordinates and the width and height. This relates to what we learned about the three parameters that defines the area. This captured area will tell offset area block to set new location of the image in this defined region. Now connect the result position to position property of hover position block. Let's run it. And yes, you can see that the mouse moved to the new offset location as defined in the offset value. In the activity log, we can see that the image was found, it was hovered, we can see the offset area calculated based on offsets we had defined, and the area of new location was hovered. This is how you can work on defining offset areas for the elements in your virtual environment. Now the next scenario will involve loop block, find text block, get text block, and set area block. We are going to work with is iterating the list of elements, where with the help of loop block, we will iterate through elements in the table. It's simple. We have to find the text in a table. You can see there are 2 rows in the table. So we have to find the text from each row in the search term and get the text from the area we will specify in the offset position. The major idea is to start finding text based on the serial number and retrieve the text from each cell in the column search term. The position that we will get from find text block will work as the input to position to offset property in offset position block. Now let's start with the loop block. The loop block iterates or loop in through the list of elements based on the minimum and maximum value defined. Like in our example, the maximum value will be 2. Now, each time the loop is executed, we have to find the text. Let's connect find text block. Connect current value to text to find property of find text block with the help of blue connector. This will help find text block to find text value on each loop. Let's expand the block and define the area from where the text has to be found. Let's capture the area. Yes, this complete area of both cells where serial numbers are there. This will be exact area in which mouse will move during loop and find the text. Since we have to find the text in the cell corresponding to each serial number, that means the mouse has to move to the new location, in this case, the cell having search terms. Let's connect offset position block. By doing this, we are passing position of the found text as an input to offset position block. This will be the position from where mouse will start to move. Now, the next step is to define offset value. Let's capture the position to offset. Simply drag the vector to the point where search term Gulliver is there. This defines the position where mouse will move to. Now, once the mouse has moved, how will you tell it the area to search the text within? To do this, let's connect set area block. The set area block in LeapWork is used to define a specific region on the screen where you want to perform actions, such as searching for elements. Here we have to search the text. Connect result position to position property of set area block. This will tell set area block about the specific area to search the text within. Let's define the size of the area. Yes, capture the cell. Now since we have to retrieve the value in this area. To do this, let's connect getTextBlock. Connect area value property to area property of getTextBlock. This will pass the value to getTextBlock and tell it about its area from where the text will be retrieved from. Let's connect findTextBlock to getTextBlock with green connector so as to ensure a continuous flow. The next step is to connect passBlock to completed property of loopBlock. This means once the loop is completed, our flow will pass. Make sure the value in maximum field is 2, since we are working with 2 rows, so here the maximum value is 2. Let's run the flow now. And yes, we can see in the activity log that each step is executed successfully. The loop run first time. The serial number is found. The mouse moved to the offset position and search the text in the area defined in set area. That was cell corresponding to each serial number. And the text in search term column is retrieved through getTextBlock. And the text is found from each row as a result of loop. Likewise, you can try reading values in other cells using offset area blocks as we discussed earlier. I would like to suggest you try these exercises at your end. This is how you can iterate through tabular data in virtual environment and automate your tasks efficiently. In summary, at first we learned about the basics of positions and areas on a screen. After this, we saw how to optimize image and text recognition by using dynamically positioned areas. We took tabular data in example. Then we learned how to work with offset positions and offset areas. This was all about today's tutorial about automating the processes involving work with positions and areas of the elements in the virtual environment. Now, as I also told in previous lessons, always make sure to take care that the screen resolution of your automation flow and your virtual machine should be same. And along with this, always take care while capturing elements' positions in the right manner, because these factors play a very crucial role in successful automation of virtual environment tasks, as it involves position of elements at each and every step. This was all about today's tutorial. We will be coming up with next interesting topics of this series and help you automate your virtual tasks like a pro and achieve high-quality outcomes as a result. For any doubts and queries, feel free to contact us through LeapWork support or connect via live chat. And remember, with virtual automation, you can transform the way your team works, cutting down on repetitive tasks and freeing up time to focus on innovation and growth. It's all about working smarter and driving your business to new heights. Keep automating, keep succeeding. Thank you for watching.